Guys, welcome back to another video. So the topic of today is GAN. GAN stands for Generative Adversarial Networks. So what is GAN? GAN is basically a type of neural network that is used for image and video processing. It basically consists of two parts. One is called a generator and the other is called a discriminator. So the purpose of generator is it is basically a convolutional neural network. And what is a convolutional neural network? It is basically a neural network that is used to generate images. It consists of an encoder and a decoder. The function of encoder is to encode the image to process the image and convert it into a noise. And then the decoder converts that noise into an image. The second part of GAN is a discriminator. A discriminator is a deconvolutional network, and what it does is it does the comparison work. It basically compares the image that is generated from the generator with a real world image, and then it sees whether it decides whether the image is relevant or not based on probability. So once a generator has say generated an image of an elephant, now what will the discriminator do? It will have its data backed up from real world images, and then it will see whether the image that is generated by a generator is an elephant or it is not an elephant. It will keep faking the process until the image is of an elephant. Until the output of a generator is true, the discriminator will provide false answer, and when the output of generator will become true, it will be shown to the user as output. So here you can see uh, there is latent space, that is basically our images, and what we do is we provide our images to the generator. Here with the help of cursor I'm showing, and what the generator does is it generates fake samples of the images according to our input. There are many you can say AI image generators in which we provide the first prompt and then it basically gives us an answer. So the prompt, you can see this latent space as a prompt, as an input that is basically provided by the user, and then it is converted into noise, and then that noise is again converted into an image according by the process of convolution, and by using convolution neural networks. And then the generator, what does the generator do? It generates fake samples of the images, and these fake samples are then provided to a discriminator. Now the discriminator will define that the image is of a elephant or it is not of an elephant. And how will it decide? It will use the real world samples of images. It will have its data backed up from any website, from the Google or the internet, from where it will have plenty of images of the elephant, like this is how an elephant looks, this is how an elephant walks, and it will actually start seeing one by one all of the real world samples, and then it will start comparing the generated fake samples of the images by the generator. And what will happen is, if the image is correct, what will it do is that it will actually save the output so that it can further get fine tuned. And and if the image by the discriminator is provided as a true, it will be shown to the end user as output. And if the image is basically the discriminator uh, gets the probability, and the image is has a less probability of being real, it provides a generated sample back to the generator. It says to the generator that fine tune this image and then again provide another sample, and then the generator provides another fake sample, and then the discriminator will compare those samples with a real world sample to decide whether the image is correct. So this process continues until the output of GAN is fine tuned, until the discriminator the probability of the image being real inside of a discriminator is high. So as the number of epochs increase in an in a GAN, in the generative adversarial network, the output is further fine-tuned, and as the number of epochs increase, the the possibilities of getting closer to real world outputs increase. So that was it from this video. Kindly like and subscribe my YouTube channel. Thank you for this video.